So today we are going to use quadratics to solve real-world situations. The difference between what we're doing today and what you've done in the past is you're going to use factoring in word problems, and you're going to have to set up the equations on your own and then solve. So let's start with the first problem. First problem, if a number is subtracted from its square, the result is 72. Find the number. Now, the first step in these problems is to translate the English sentence into a mathematical sentence. So, what might be included in a mathematical sentence when you're looking for a number that is subtracted from its square and the result is 72? How are we going to translate this? Michael?
A variable?
Yes, what are we going to use for the variable?
N.
N, sure. We'll use n for the variable. So we're using n for the variable. What are we going to do when it says that we're subtracting a number from its square? How do I write that in mathematical language? Sam?
Well, I said the square root of n minus, or the square root.
You're getting?
N squared.
N squared, okay. So n squared, what did we do? So here's our square. What are we going to do with this n here? Subtract it, okay. Is a very mathematical word. What does is mean? Does not mean multiply. It does mean equal. So whenever you say is, you can just magically put an equal sign. It always means equal. So what goes on the right side of the expression? Nick? Excuse me? 72. All right. Okay. So we have a quadratic expression, n squared minus n, is equal to 72. And essentially, we need to solve this. Now, in order to solve a quadratic, two things must be true. What's the first?
Or it must have it.
What is the first or second thing? What must be true for a quadratic to be solved? Josie? It must equal 0. Does this equal 0? No. All right. So what are we going to do to both sides of the equation to... Oh my goodness, you didn't even finish my sentence. You subtract 72. All right. Do I have a common term on the left side of the equation that I could subtract 72 from?
No.
No, Beth's shaking her head vigorously. No. So I'm left with n squared minus n minus 72 is equal to 0. Okay, so I've met the first condition. It is criteria. It is equal to 0. So what is the other thing that must be true of a quadratic expression in order for us to solve it? By the way, this doesn't meet this second criteria. Sarah?
It has to have a greatest common denominator.
No, it does not need a greatest common denominator. Although it could, it doesn't have to. It has to be in factored form. It's got to be in factored form.
Oh, understood.
Right now it's in expanded form. We need to factor it. So go ahead and factor this. Go ahead and factor it. All right, so while I'm looking at this, I noticed there are no greatest common monomials, so I don't have to worry about that. 72 is not a square, a perfect square, so I know that it's not a square binomial or a difference of squares. So I know that I'm going to end up with a binomial pair of factors. Those people have been following along. That means we need to have our rectangles or we need to have our factor sum table. The one thing I will point out is, since this last term is negative, that means we're multiplying by a positive and a negative. And this is a 1. So we're looking for two numbers that are multiplied together to equal 72, but add together to equal negative 1. Let's see if the class has figured it out yet. All right. Do I have any volunteers to give us the factored form expression of n squared minus n minus 72 is equal to 0? Sophie?
Is it n minus, or is the quantity n minus 9, and to the quantity n plus 8?
Well, let's double check. 8 times negative 9 is?
Negative 72.
All right, that works out. Negative 9 plus 8 is? All right, so we factored it correctly. But we're not done. We're not done. So we need to solve now. So how am I going to solve this, Sarah?
Well, you draw a line down the middle and then figure out what n would have to equal to for each side to equal 0.
Okay, so how am I going to get the n by itself here?
-8.
Subtract 8 from both sides? Okay.
No.
So I get n is equal to negative 8. All right. On this side, what am I going to do to both sides?
Add 9.
Add 9. So I get n is equal to 9. So is it possible, given the criteria of this sentence, that we have two answers?
Yeah, sure.
And I will prove why it is. So we are going to square both these numbers. So what is the square of negative 8? Negative 8 times negative 8.
64.
64. Minus the number, in this case, negative 8. 64 minus negative 8 is? 72. Because subtracting negative is the same as? All right, so that checks out. So our other answer of 9, what is 9 squared?
81.
Minus the number, which is 9. 81 minus 9 is? Oh, look at that. They both work, don't they?
so crazy.
All right. Yes?
Well, on the algebra sheet there was one and it was in parentheses. Like, it wasn't.
We are going to get to one just like that in a moment.
Okay.
Okay.
So to figure out the factored form, you do factor sum table, right?
In this case, a factor sum table would work, yes.
Excellent. But you could sort of do it in your head too.
Well, yeah, because you know that negative 9 times 8 is equal to negative 72, and they're 1 apart. Okay, so let's try the second problem. The second problem, again, is a little abstract. We're not talking about an actual circumstance. We have find two consecutive odd positive integers whose product is 143. Do we know what the number is? Do we know what the number is?
Yes.
No.
Oh, no.
No. What are we going to use since we don't know what the number is? N. Okay. So let's assume that n is the smaller of the two odd numbers. You can, if you wanted, you could assume it's the larger of the two, but what is the other number going to be in terms of n? And remember, this is an odd number, and it's going to be larger. Aiden?
N plus 2?
Why is it n plus 2?
Because consecutive means that they're right next to each other, but since they need to be odd, it's adding 2, because if you just added 1, then it'd be even.
Okay, sounds good to me. So product, what does it mean by a product? What do we do when we're trying to get a product? Marcos? No.
No, you multiply.
Oh,
Marcos? You multiply, okay. So we have n times n plus 2, and oh my goodness, this math magical word shows up again. Equals. Equals what?
143.
Now, Livy, you asked, well, what happens when you have something like this? So here's the thing. This is a factored form expression. We're going to have to expand it to deal with this non-zero number over here. Okay, so let's go ahead and expand it for now.
I thought it had to be in factored form.
It does need to be in factored form, but wait. But wait.
Oh, goodness.
So, is this equal to 0? No, and this does need to be equal to 0. So what are we going to do to both sides to make it equal to 0?
Minus 143.
Minus 143. Minus 143. Now, here's the thing. Here's the thing. Do I have any common terms that I can subtract this with? And the answer is no, because you do need to realize that this is n times n and this is n times 2. So really, n times n is?
N squared.
N times 2 is?
2n.
And then I still have my negative 143. And what does that equal? because I subtracted 143 from both sides.
Oh, but you have but
Equals 0. 0.
So, is this now equal to 0?
No. Oh, wait, yes.
Mark this is.
Okay, I would suggest before you call out, you think about the question first. Throwing that out there.
Oh, sorry, I thought you meant that.
Okay. What is the second condition that must be true in order for us to solve a quadratic? Beth? It must be in factored form. Is this in factored form? No. So now you need to factor it right now. Incidentally, this isn't too bad. Go ahead and factor it. When you have the answer, stand up. When you have the answer, stand up. By the way, if you are reading Mark Twain, perhaps it's on a Kindle or something like that, I will keep it permanently.
It's a Nook and it's Tom Sawyer.
Whatever. All right. So, go ahead and factor it. Stand up when you have the answer. Now, while the class is working on this, you see that there's no common monomial because there are no n's. Sure, if you'd like to use a calculator. And 143 is not a perfect square. So again, in this circumstance, you're looking at a factor sum table. So you're looking for two numbers that multiplied together equal negative 143, but added together equal positive 2. This is factorable.
Wait, is it not negative? Oh, factor
143 is not prime.
Wait, is it factor of 2 or factor of?
It's factorable. It's factorable.
How do you figure that out? You're so smart.
I just went through all the numbers.
Tell me what's flow.
Wait, what are the factors?
All right, Sarah, could you please tell us what two numbers multiplied together equal negative 143?
Negative 11 and
Could you say it one more time, a little bit louder?
negative 11 and positive 13.
How do you figure that out?
What term goes here?
And
13?
So,
Oh, yes, right, guys.
so 13 times negative 11 is negative 143. 13 plus negative 11 is positive 2.
Oh, man.
So it works. Excellent. Are we done?
No.
We now need to solve it.
Solve.
So Michael is yelling from the back that we need to make them equal 0. All right. So what's going to go right here? What's going to go right here? Yes, ma'am?
Plus 11.
Positive 11. So n equals, that's an h. It was never an h. So n equals 11 on this side. What does n equal on this side? Kira?
Minus 13.
So we have two answers. Is it possible to have two answers in this one?
Yes. Oh, yes.
No.
Again, before you call out, use your brain. What's it say in the question that tells you we are only looking for one answer?
Oh, no.
Ashby?
Oh, what?
Oh, I know.
Stella?
It's, wait. It has to be a positive.
It has to be a
So
positive.
it'd be 11 is your answer.
Okay. Hold on a second. So we know that n is equal to 11. What is the other n going to equal?
13.
So our two numbers are 11 and 13. Well, you can't just get rid of it. But the thing is, time out. So we're saying that n is equal to 11, right?
Yeah.
So, and we have the other number is n plus 2. So
11
this-
plus 2.
we have 11. That's h again.
Oh, and then you just add.
So we have 11 plus 2 is equal to 13.
Oh, so you just did it the other way.
All right.
Really?
So
I did not understand.
moving on to the next question.
Okay, I don't know.
Moving on to the next question. Now this one is going to be much better off if we make a diagram. So we're going to do that in a moment. It says find the length of a rectangle. sorry, the length of the rectangle is 6 centimeters less than twice its width.
Whoa.
Find the dimensions if its area is 108 square centimeters. So what we're going to do now is I'm going to move this up to give myself a little more room. All right. So I'm going to, okay, so we all know what problem I'm working on. All right. So what shape are we dealing with?
Rectangle.
So what should I draw? A trapezoid. You are very, very, yeah, hilarious. All right. So what is the width of this rectangle? Do we know?
No.
No, we don't. So when we don't know the width of a rectangle, what are we going to use?
W.
W. Okay. I would go with W too. All right. Now, what clues does the problem give us in solving the length? Michael?
It would be W, like square root W, then minus 6.
Is twice square rooting?
Oh wait,
No.
no, it's not.
So what does it
W
mean?
divided by 2.
If something is twice, what are you doing with it? Aiden?
2W
2W. So you're multiplying. Twice is
Minus.
multiplying by 2.
Oh,
and
less
then minus 6.
So we have 2W. That's the twice the width. And it says 6 less than twice. So that's minus 6. And what is the area of this rectangle?
108.
108. All right. So how do I find the area of the rectangle?
We already know the area.
How do I find the area of the rectangle? That's I should rephrase that. How do we find an expression that is equivalent to the area of the rectangle? It's not going to be 108 in this case. Sophie?
So wouldn't you do 2W minus 6 times W equals 108 and then like play the game?
This is just like this previous problem right here, isn't it?
Yeah.
So what's the first thing we're going to do? What's the first thing that we needed to do in the previous problem? Michael? W?
Minus 100.
We absolutely could subtract 108, but even before we did that, what did I do?
Divided by W.
I expanded it. So W times 2W is?
2W squared.
W times 6? Negative 6.
Negative 6W.
And now Mr. Michael?
No,
Now minus 108 from both sides. Do I have common terms?
No.
I do not have common terms. So I'm left with 2W squared minus 6W minus 108. And that all equals? 0.
0.
So I've met my first condition of making it equal 0. However, it is not in factored form, is it?
No.
So this one is a little bit different in factoring. What's the first thing you look for when you factor? Sarah?
GCM?
Greatest common monomial. Does this have a greatest common monomial?
Yes.
It does, doesn't it?
Wait,
2.
2.
2. Oh.
So the 2 gets set out to the side. And we have W squared minus 3W minus 54. And that equals 0. All right. So right now, go ahead and factor that trinomial.
Now it's so much easier.
It is a lot easier this way. Thank you, sir. So again, a factor sum table will work on this one, or your rectangles. What two numbers multiplied together equal negative 54? What two numbers added together equal negative 3? Let's see if anyone has the answer. I'm guessing they do. Do I have any volunteers for the correct factored form expression on this one?
Yeah, dude.
Livy?
So you do 2 and then W minus 9 and then W plus 6.
All right, now the only sort of weird thing going on here is there's no variable here. So we're actually going to kind of ignore that 2 for now. And we're going to split it apart just like always. So we have 0 is equal to w minus 9, and w plus 6 is equal to 0. So what's w equal to here? 9. What's w equal to here? Negative 6. Is it possible to have a width of negative 6?
No.
No, it's not.
Silly.
So this answer makes no sense in the context of the problem. Therefore, the width of this is,
Wait, how is that possible?
you can't have a negative side length of a figure.
Yeah, then we would
So the width,
get to the front.
so the width is 9. So we have 2 times w minus 6, so the length is?
Negative 54.
No, 6.
12.
2 times 9 is
12, so
18, minus 6 is?
What do you do with the 2 then?
Wait, then 12 times. Wait.
12 times 9.
We had 2 times w, which is 9.
So the width is 12.
The width, the length
Oh,
is
goody.
the length is 12. The width is 9. So this 2 doesn't end up affecting the equation or the solution.
Do you know that there's the first, second?